Hello, everybody. I'm Julian, and I'm just getting everything set up. Let's see here. Boom. There we go. So, good afternoon, everyone in Australia, and good day from Sydney, everyone from wherever you are in the world. We're going to give this talk. I'm going to do the first half, and then Romain is going to finish off the second half. We've both been developers on the Underworld side through the BGH. And so this is our talk. I'm going to cover off some retrospectives, looking at how the Underworld project evolved through the BGH. I'm going to talk about some outcomes we had during the BGH, and then we'll talk about technical updates, and Romain will talk about them, limitations, our plan going forward, and the need for community. And Dietmar, that's wonderful to see that G-Plate has such a wonderful community, and I love the pasta idea. That's brilliant. Well done. Okay, moving on. So the Underworld core development team, let me introduce us. We're led by Professor Morazi at ANU, and the core developers are Romain, Beucher, Rebecca, John, and myself, Julian. And we were all centered at Melbourne Uni when the BGH started, and since then we've all dispersed around Australia, so, well, the eastern part of Australia. So that's the core team, and we're helped a lot by a big support team, and our support team includes developers, collaborators, and students in our project. And this is just a sample of many that have worked in the BGH, and there are many more too. I couldn't fit everyone on the page. So big shout out to everyone there. And to mention, we also have a community outside of Australia as well that is quite big. And this is a snapshot of the new users we took on last year, or the users we got from last year. And we see big increases in the US and in China last year, which is really good. One of the people on the previous slide, Ting, has gone back to China, and he's teaching people how to use it there. So that's wonderful. Okay, so from a historical perspective, Underworld, how it was before the BGH started. Well, Underworld, let me turn on my pointer here. This could help. There we go. Underworld was a parallel finite element and PIC framework used for thermomechanical modeling. And the FEM is represented here by that mesh you can see. That's our standard discretization. We solve things like velocity and temperature for the model. And PIC are these particles. Those particles are particles in cell, and we endow those particles with material properties like viscosity and density, and we advect those particles across our mesh that we solve. That was always Underworld's bread and butter. But the way you set that up before the BGH was through these XML files, which were big, ugly files that were quite long, and they were quite haphazard to do things like coupling to other codes, which is part of something we're very proud that we've got Underworld to couple with Badlands. And it's quite difficult with the XML files. Not to mention, XML files also had this difficulty in sharing what was exactly going on in the model. They weren't really descriptive in a good way. And we ended up having a very stagnant kind of interface. It was not dynamic in any way. The user experience was quite difficult because they were given this very static text file that they had to input all their commands in. And there was a need for a big update. And so over the course of the BGH, we've really worked hard on improving our user experience and improving the usability of our code. We've maintained the parallel FEM and PIC framework, which is used for thermomechanical models, but we've simplified the interface, and we've simplified it using Python. And using Python, we've really enabled a dynamic way to describe models, and we've called that UW Geodynamics. And UW Geodynamics really allows users to be a lot more expressive in just declaring certain things in their model. And here's an example of a 3D subduction model that I've been working on last year. It's all described in UW Geodynamics that we're going to use a lot this year for investigating various slab mechanics. I think Andreas will talk to that later on tonight. Also, going with Python has enabled us to use Jupyter notebooks for preparing our models. And Jupyter notebooks are wonderful because they are dynamic and users can quickly engage with the commands they've written and debug their models on the fly. This allows for coupling with other community codes too, and you can test that one. This is all driven by Python and Jupyter notebooks. A big takeaway of all this is that we've used technologies like Docker and Binder Hub as well. And Docker can capture the runtime environment that we use with our Underworld code and other software stacks. And that means we've unlocked a way to really preserve a model's version and the information put into the model to create the model outcomes. So with regular releases, we've had these big successes with creating stable models and models that persist in time. And we've also had significant, we've shared this expertise and these technologies with other members of the BGH. And a good example of that is with the BGH Atlas, where the Atlas is got behind it references to GitHub repositories and other online repositories. And the model provenance is preserved within those repositories. And using Docker files, we've preserved the runtime for those models. So we really get back that reproducibility of the models that we're looking for. This also enables us to have cloud execution available, and we can hook our models up to Binder. So you've got live demos available, which is something really nice. It's sometimes not useful for big 3D models, but it's really good for exemplars. So really, the outcomes of Underworld during the BGH, we unified a workflow with all these technologies. The workflow going from setting up the model on your laptop and then deploying it on a HPC machine like Giordani or Pawsey. We've coupled codes with Python, and that really means, harnessing the power of NumPy, this low-level Python module that is the lingua franca of Pythonic codes and makes coupling quite easy and has enabled a lot of the technologies you'll see in these BGH presentations. We've fostered a lot of expertise with using Jupyter notebooks and Dockers and spread that to the community. We've also built community practices, and those community practices are reflected in the way we have set up a GitHub. We've set up GitHub communities, and Romain will speak to that later on. Taking all these, we've put our codes up as open source, and we've had different users, take on our codes and produce science outcomes. And I've got some examples here that perhaps Patrice and Romain will touch on later in the talk. Another big outcome of our effort in BGH was that we got 2 JOS papers published on Underworld and our UW Geo layer. And these are really important because they represent like a significant amount of documentation and, style of making the code usable and accessible for users. And they also provide a citation for using our software. So that's, I think, where I'm going to leave this talk and then hand over to Romain. Romain, over to you.
Yes, I'm coming. Can you see my screen? All good? Okay,
all good.
Great. So so I just wanted to touch base about, on the things we did last year in 2020 in terms of technical updates, and just discuss our vision on the philosophy we would like to carry forward beyond the BGH. So what we did last year, so UW Underworld and UW Geo 2.10s are now available. We've got 2.11 coming soon in February. So these releases have been mainly maintenance releases, but we've also added some interesting things like we can handle non-Cartesian geometries like annulus. We are also it's easier to install on different platforms now. We've also worked hard on developing an Underworld cloud. So we've had idea of providing really a teaching platform for students, which I think is going to be very useful, especially in that new COVID world. But one of the things we really worked hard on was like interfacing Underworld. And you've seen like many examples on how that Python interface allows us to couple Underworld with codes like Badlands or even Gplates. And so I remember putting that slide like 3 years ago when I started. And what I really wanted to do was like some kind of unified workflow where I could look at mechanical stratigraphy, sediment thickness, seismic stratigraphy, and data like such as thermochronology. And so to do that, last year we worked on developing a range of new tools to interface Underworld with different new products. Of course, we have Badlands. You've seen many examples of Badlands to do like surface processes coupled with Underworld. We've got now also Quagmire, which is highly parallel surface processes code. I've released recently PyF tracks, which allows you to predict fission track data and like really predict like so fission track, apathetic fission track ages, track length that are really important to calibrate the temperature of field. We've got Tonic to look at phase diagrams and phase transition and things to starting also to look at optimization, how to produce swarms of models and look at the parameter space. So we've got Romain who developed Everest, which should be available on GitHub. And I'm working on PyNA to do parameter space search optimization. And another important point is we are trying to do data integration by interfacing our code with online databases. There's like the OS GeoChem portal that is putting together Bioscope that has a REST API, so you can interrogate the database for different things like thermochronological ages or shrimp ages, whatever. So all of this available on our GitHub, and I really encourage you to have a look. So one other thing is we have now a new way to install Underworld that is much easier. That's an alternative to Docker. So you can get Underworld through our Conda channel, which is called geo.under. And so you've got all sorts of packages of software developed by us and BGH. So Badlands available, UWGeo, Underworld, StripeEye, etc. So now it's very easy to install it. It takes roughly 2 minutes. You just do a conda install Underworld, and you're ready to go. So in terms of so what we learned from the BGH, so I think BGH highlights some limitations on what we can do and what still need a bit of work. We always had that issue with resolution, so we would like to go higher resolution. 3D models remains very challenging. They are time consuming, and they are obviously very costly in terms of computing time. We would like to do global models and add more complexities, which like more non-linearity in our system. And there's also always that balance between usability and capability of the model. An important thing also in the BGH was to how we do the training and how we transfer knowledge. There's some expertise that takes time to acquire, and but we need to find a way to improve that. So so we've got these two pieces of software, Underworld and UW Dynamics, that are based on the same core, but with Underworld being very versatile, allowing you to do lots of very interesting things, but with a steep learning curve. So clearly designed for more advanced users. And so our response to make it easier was to develop UW Dynamics, which has a rather limited API, but a smooth learning curve. And so the way we are trying to address all these limitations now is to develop a new code that we've been working on. So that's the next iteration of Underworld 3. And we really want to stress the importance of the community around this, also to help like keep working on the effective, very efficient workflow. But of course, we want to build on these things, so keeping the API as it is now. So just make the code more efficient. And to do that, we want to try to go to the 10,000 processors mark. So it's been quite a lot of work, but we've seen like some interesting things on Giordani and POSI. So hopefully will be possible soon. And that's what we need if you want to do large scale high resolution and global scale models. In terms of communication, so we have like a range of media. We've got the Underworld Geodynamics community website that I encourage you to look at. There's like a lot of documentation that we keep updating, and we keep adding new things, new tutorials. Of course, Twitter. There's a GitHub community space where you can share your models and get feedback from us and from the global community, with the idea of really like putting together all the code that students and researchers are developing. What we really want is that no code get lost, and that everyone can benefit from it. There's a new blog website that came out last year, which is the Giordani blog, where we invite people to write blog posts about, not just about Underworld or even geodynamics, but like a wider audience around geophysics in Australia and around the world. In terms of sustainability and going forward, so we now have a standard workflow for the Underworld community engagement via GitHub. That's we want to push forward. There's a system with one GitHub repository per project, including Docker file to ensure reproducibility. Sorry. We had quite a few interesting pull requests last year with interesting interaction. And so again, I encourage people to look at our GitHub and submit pull requests, issues, every question you may have. There's a large library of models available. They are not all on GitHub yet, but we are working on it. There's the Atlas, of course, for the BGH. And what I really want to stress is that everything is open source, and it's not, what we mean by that is not that the code is available, but it's easily available, and that we accept contribution, documentation, tutorial, learning material from everyone. There is multiple ways to do things, and we acknowledge that. There is no, so please send us your contribution. The core team is there for support and to provide an ethos of practice, but the code is yours, and again, happy to receive any contribution. In terms of long-term technical plans, the future versions of Underworld are to bring these Underworld and Underworld geodynamics layers closer together, but we want to retain the simplicity of Underworld geodynamics. We also want to keep maintaining Underworld 2. We want to go to large 3D, 4D high resolution models with regional and global scale. Underworld 3 is coming later this year, hopefully, with an updated sea layer, with the idea of using thousands of CPUs on Giordani, and leveraging PETSI over existing code. And what we really want to do is we want to focus on the user experience. Yes, carry that forward. So I just leave you with that and the link to the Underworld Code organization on GitHub. Thank you. Any questions?